everyone, and welcome to the Rajasthan International Center. Before we begin our talk on India's space story, we regret to inform the sad news that renowned space scientist and former chairman of ISRO, Dr. K. Kasturi Rangan, passed away yesterday. We shall now observe a minute's silence in his memory and pray for him. Thank you. The Jigyasa Forum, as its name suggests, aims to nurture curiosity and inquisitiveness. It has organized over 150 talks on varied topics with subject matter experts. It was originally founded by some university scholars and former civil servants, and since 2019, the Association of Retired All India Service Officers has been managing the forum to foster lifelong learning in them. However, it welcomes members of the wider community to attend the Jigyasa talks. Today is the second in the series of talks being organized at RIC. RIC has emerged as a vibrant center of cultural and intellectual activities in Rajasthan. The association and RIC are now collaborating to invite some of the finest speakers in our country to provide the audience a stimulating intellectual experience. Our chair for today's talk is Shri Umesh Mohan Sahai, President of the All India Services Pensioners Association of Rajasthan. I invite Sir to please take the dais. Welcome, Sir. Mr. Sahai belongs to the 1977 batch of the Indian Forest Service. He retired in 2013 as the Principal Chief Conservator of Forests. He has been a member or chairperson of a number of Government of India committees. He is an outstanding sportsman and has won around 20 medals in various national tournaments. He's fond of light music and Urdu poetry. We'll take a minute to welcome Sir. Welcome, sir. I take great pleasure in inviting our speaker, Dr. Dinesh Sharma, on stage. Dr. Sharma is an award-winning journalist. His latest book shows how India, even while grappling with poverty and hunger, slowly became a world leader in space research. A couple of examples of the nimble innovation and determination of our scientists. Imagine this view. Before launching a rocket that will swiftly and speedily whoosh into space, the pieces are being gently carried in bullock carts, moving at a slow pace, as the bumpy Indian roads made that the safest way to transfer the pieces of the rocket. Or, imagine the cost of bringing an epic Hollywood film like Oppenheimer to the theaters in July 23. In half of that cost, welcome, sir. In half of the cost that took to make the film Oppenheimer, in August 23, India landed Chandrayaan-3 onto the moon. The book has many such stories over a span of 6 decades. With a feeling of pride, I invite Mr. Nihal Chand Goyal, Director RIC, to please felicitate our esteemed guests. Thank you, sir.
नहीं नहीं
Now I welcome you, sir.
yeah, thank you.
Thank you, sir.
Thank you.
When our astronauts like Kalpana Chawla, Sunita Williams, and others travel in space, they leave their phones away for months. We can surely and kindly please put our phones on silent mode. Thank you. I will now request the chairperson to please formally introduce our speaker. Thank you, sir.
Good evening, friends. In the series of Jigyasa Talks, today's talk would be delivered by Dr. Dinesh Sharma on the subject India's Ascent, the Untold Story, Untold Space Story. Dr. Sharma is an award-winning journalist, author, and media trainer with nearly 40 years of experience in reporting on science and technology, health and environment for national and international media outlets. He is a prolific writer. His books have focused mainly on public policies and India's science and technology journey in post-colonial period. His latest book, Space, the India Story, deals with the journey of Indian space program, while Beyond Biryani, the making of a globalized Hyderabad, published in 2024, is about the dramatic transformation of eco, of an ex-princely state into a technology hub. For his book, The Outsourcer, the story of India's IT revolution, published by MIT Press USA in 2015, he was awarded the prestigious Computer History Museum Book Prize instituted by the American Society for History of Technology, SHOT in short, in 2016. Another book, Indian Innovation, Not Jugaad, featured 100 innovations that have transformed India in the past 75 years. He has been the Jawaharlal Nehru Fellow from 2020 to 2021 and New India Fellow in 2007 and Scholar in Residence at International Center, Goa. As part of International Scientific Expedition in 2008, he traveled to the Arctic to report on climate change. His academic experience includes teaching a course in development journalism for MA student at, at Ateneo de Manila University, Philippines. He's teaching fellow at the JNU also. He's a doctorate from BHU and PG in communication and journalism from Osmania University. He has been the science editor as Mail Today of India Today Group from 2007 to 2014. And from 2017 to 2019, he is the founding managing editor at India Space Wire, India Science Wire.
Science.
He is the regular contributor to the medical journal, The Lancet. Now I will invite Dr. Dinesh Chand Sharma to deliver his talk on the subject. Thank you.
Thank you, Mr. Sahai, for those kind words. I'm truly delighted to be here this evening to speak to such a galaxy of, former civil servants and young audience here. And I thank the Pensioners Association, the Rajasthan International Center for arranging this talk and inviting me to speak on my latest book, which happens to be on the space sector. It's a relevant topic today because this is the 50th year of the first Indian satellite going to space, that is Aryabhatta in April 1975. Recently, we also celebrated the 61 years of the first human going to space, that is Yuri Gagarin. And unfortunately, we are also observing today as the day when one of the foremost, architects of the modern space program, Dr. Kasturi Rangan, passed away, which I'm going to touch upon some of his contributions during the talk. And of course, it's such a happy coincidence that, happy occasion that Jaipur is a city of science, a great heritage of science and astronomy and several other fields. Rajasthan has been there. It's a city of knowledge and learning. So I'm truly, truly delighted and I feel privileged to speak to all of you today afternoon. I also face a kind of identity crisis because, of course, you mentioned my book on Hyderabad. I live in Delhi. I'm from Rajasthan in some ways, in the sense my grandfather was here and my father migrated. So it's a story of migration. So when I wrote this book on Hyderabad, people said, Acha, how come you're from North? Why are you writing a book on Hyderabad? But during the tea, somebody asked me that, okay, when I said the book about Hyderabad, so you are a Sharma, because there are also Sarmas in Telugu. So I always face this identity crisis, but I feel at home when I'm here. And also I feel equally at home when I'm in Hyderabad. So that's a story of many of us, I would say. So I have not prepared a big presentation, but I'll show you some interesting pictures because I can also begin with a disclaimer that I'm not a scientist. I've been a science writer, so that gives me some freedom, and I've not been part of ISRO or any other government organization. So whatever I say and observe and whatever I've written is as a student of science and technology in this country, the policy making processes in this country. Of course, I had a direct experience in the sense of writing on all these subjects since I started my journalism career in 1984. And I've had the opportunity to interact with many of the policymakers, especially in the scientific departments like Professor M.G. Kemer and Seshagiri, and several of them, including Dr. Kasturi Rangan, Dr. Kalam, and several others. So I have that first-hand experience, but this is not an anecdotal experience which I'm going to share, but I have relied on a lot of archival material. I have interviewed people to know more about the space program, and that's how I put together this story. And this is so my general interest in how things happen in this country. My first book was on the information technology industry. So I didn't start, most stories would start with the Rajiv Gandhi era, when the first computers came, or when they started banking computerization, or when then post 91. But I always ask a fundamental question that how did the first computers come? And when did they come, and why did it happen, and how did it progress? So the questions which I tried to answer through all my books is that what has been the journey of where we are today? That's what I have tried to answer in Hyderabad, because Hyderabad is not a story of just Chandrababu Naidu, which everybody would say, okay, he did a lot. But of course, that was part of the story. So I go back to 100 years. Like in computer book, I went back to the time first computers came in 30s and 40s, and Mahalanobis and Bhabha started using. So that's what personally interests me, to answer that question, that how did things begin? So that's what I'm going to do today with the space story also. So as Sisodeaji suggested it, I put this catchy thing, that untold space story. So I'm not going to, don't expect any great visuals of rockets and which, you usually see the satellites and the scientists dancing or, celebrating in the control room, all those images you've seen. So I'm going to show you some different aspects, and through them I'm going to tell some aspects of the space program which I hope are new to you, because many of you have had personal experience of working in the government, and maybe you have worked in scientific departments also. But let's see how it goes, and I find some young audiences also at the back, so hopefully it will interest all of you. So this is a picture which any guess, which year this could have been taken? Any wild guesses?
For 50s, around 50s.
Yes. नहीं, एक बताइए. Yeah. No, this is a picture taken in 1961. And of course, not very far from the 50s if you said it. But the point which I want to make is this picture tells a lot about what India was, and not very different in 50s and 60s. You find that most of the people are not I'll come to that, yeah. No, this picture was not there in the web series. No, it was not there.
वो क्वेश्चन आंसर सेशन में डिस्कस कर लेंगे.
This is a picture taken in 1961, somewhat connected to the pre-space program. You see that, nobody is wearing footwear. People are wearing headgears, and there is some kind of scientific equipment there, and there is a truck. So this picture was taken when scientists were engaged in something called the balloon experiments. Before even sounding rockets are fired from Tumba, they were engaging in balloon experiments to study the upper atmosphere. The balloons with instruments would be flown. That was a large experiment done by Tata Institute of Fundamental Research under Dr. Bhabha and Sarabhai. And the instrumentation will collect the data, and after some time the balloon will fall at some place, and this van would go and collect it, and somebody would be tracking. And this is a picture of that balloon being collected when it fell in some place near Hyderabad. This was a Indo-US balloon experiments in 1961. The idea behind showing this picture is how difficult it was to do science in a country which had almost 60 to 70% illiteracy, which had no basic infrastructure like telephone lines, and these balloons used to carry the address that it in different languages. That suppose it falls in your village, you contact so and so, but it didn't have any telephone number because there were no telephone lines. There was a self-addressed postcard which used to be in the instrumentation, that if you find it, just mail it back to the collector or to us and we'll collect it. So the idea is that we did not have, we had all the problems you could imagine a newly independent country in the 50s and 60s, very high literacy rate, people dying of hunger, diseases. The 60s was a period when we had the ship to mouth, kind of a situation. And there were not many engineering colleges, just 2 or 3 IITs were functional at this time. Of course, India had a good tradition of science. We had already a Nobel laureate in the pre-independence era. Science was happening in, universities. But in technology, we were lacking. So even basic instrumentation had to be imported. So we didn't have that kind of a network of CSIR labs, which we have today. They are just being built. So educational, facilities were lacking, infrastructure to do science was lacking, even basic infrastructure like moving on the, in areas was difficult, so we didn't have telephone lines. So in such a situation, when the country was facing large number of problems, to talk about science, to give a preference to science, and that too a new emerging area of space. 57, the first satellite was launched, Sputnik, and nobody knew what space technology holds for us in future. So to talk about science and to talk about specific areas like atomic energy and space and electronics at that time was a bit audacious if you come to think of it today. I mean, today we can talk about AI, machine learning, because we have so much, infrastructure to support that. We have built, technical capabilities, we have institutions, we have everything, we have research funding agency. But imagine a situation when none of that existed. Forget about teaching of space science. We didn't have basic engineering colleges. Just for these 2-3 IITs, IIT Kanpur came up in the 60s, but we had just Kharagpur and one other IIT. Bombay was still to come up. So to do science at this time, this situation, and to have a policy saying that science is going to contribute to national development. It will be used for meeting all the deficiencies which we had. I think it was something unthinkable in any developing country at that time, because so many countries became free around that period, but none of them thought. We had the Scientific Policy Resolution of 1956, which clearly laid out that yes, science and technology will be used for national development. So that was a clear vision which we had. We talked about science, we talked about scientific research, we talked about scientific temper, we talked about removing irrationality, we talked about promoting rationality. All that was there in the Scientific Policy Resolution. So the number one point when we talk about science and technology in general, and when we talk about space, atomic energy, and all these high science, high-tech areas, to remember is that we had a clear political vision to do where we want to use science. So I think this is the picture which is often we should remember that, yeah, it's science started in this country under very difficult circumstances. There was a crunch on resources. I mean, everybody wanted, the steel plants were being set up, pharmaceutical companies, IDPL was coming up, and agriculture research needed money, medical research needed money, CSIR, so many labs were coming up. So there was a competition for available resources. Foreign exchange was not easily available. I mean, some of you have been in the government, so you would know that we had to apply to the RBI. If I wanted to travel to Europe, I had to apply to RBI with an application saying that I need $100 and I'll be using this money for this purpose. So, I mean, imagine think of science in such a situation. I think that was the beginning point if you want to really understand any area where you have done well, whether it is information technology or space or atomic energy or defense research. We have to think that science started in this country under very difficult circumstances. So, of course, that grand vision was there. But to translate that vision, what you need is people, policies, programs, and projects. So, who of Nehru? I am not showing any regular picture, so don't expect me to show Nehru here. I mean, I'll come to this picture. So you needed people. So of course you had advisors like Bhabha, Mahalanobis, and Bhatnagar who are advising Nehru in planning science, even expanding Department of Atomic Energy, CSIR, and of course space research was born out of Department of Atomic Energy. But having these advisors, policymakers in scientific departments alone was also not sufficient. You needed people to implement those programs. You needed trained people. How did we overcome that? I mean, if you want to start a program in any area, how do you do that? You need people trained in that discipline. So we didn't have that kind of a manpower. Of course, as I said, we are doing very good in fundamental research. There were institutes which were doing very good, but we didn't have manpower to run if we wanted to apply that science for national goals. So in that kind of a situation where of course we had the larger policy perspective, within that we had to think of what specific areas can do. So among the advisors of Nehru was of course Bhabha, and along with Bhabha I showed you the balloon experiments. So Bhabha was also working with Vikram Sarabhai. So they were undertaking balloon experiments. Sarabhai had, just like Bhabha had established Tata Institute of Fundamental Research, Sarabhai had established the Physical Research Laboratory in Ahmedabad. So they were all private institutions. Imagine, PRL became a government institution much later. TIFR, of course, was a tripartite agreement between government of India, government of Maharashtra and the Tata Trust. So institutes are being set up in the private sector. So he was heading PRL and TIFR was headed by Sarabhai, and both of them were working in the cosmic ray research or the upper atmosphere studies. So Sarabhai's vision to do science and space science was driven by what was happening in the 60s, you know. Of course, we know the rivalry between Soviet Union and America, that who will reach the moon first. So a space race had begun at the beginning of the 60s, and by the end of the 60s, we had the first human, you know, walking on the moon. But Sarabhai clearly said that if we want to do space technology in India or space science in India, we don't have the fantasy. I can read out the exact quote. What he meant to say was, we are not going to be part of this space race, which was partly to establish the supremacy of one superpower over another, or to militarize, or to have a greater number of missions to space, to outer planets. He says we want to do space research for national development. So within the scientific research policy, policy statement, we had the goal of using science and technology for national development, and a subset of that, Sarabhai had his own vision saying that India should use space technology for national, to address problems like poverty, hunger, lack of health policies. So one way to overcome the shortage of people was to send them where they could be trained. I mean, we couldn't have waited for engineering colleges to start or IITs to start teaching aeronautical engineering or aerospace engineering or space. So the first set of recruits which Sarabhai recruited at the Thumba Equatorial Research Station was sent to, and where else but to NASA. So you can identify this person, I suppose. Any guesses? No, I heard some name from that side. Yes, that is Dr. Kalam. So one of his first assignments after Sarabhai recruited him was to send this bunch of persons to NASA for first-hand training. So it was, while there was rivalry between Soviet Union and America, there were also kind of a talk of using space as an international a means for international cooperation, where countries should cooperate, because space is such a common heritage for all humanity, so everybody should work together. So that kind of a spirit was also there. But it was also a kind of a tool which both the superpowers were using to attract countries in their own orbit. That we have learned many years later, when the documents of NASA and US Department became out, that space, NASA was used to get countries in their own orbit. But here India was needed to quickly have a space program, and the best way is to send your own people, because we are not doing space at that time. To do something from scratch, you need people and you need trained people. So this was one of the means. I mean, several people went to several universities, people who were working in American universities, MIT, Caltech, and also some people in NASA were to come back. Like Dr. Kasturirangan wanted to go to US, but Sarabhai stopped him after he did his doctorate from PRL. So he wanted to do his postdoctoral work in America, but somehow he convinced him. So by all means, everything was put together to bring people back, to retain them, or to send them abroad under bilateral, under UN agencies, to build a core of people who could do research or to work on space programs. So just remember these two people. So those are the two people you saw in the previous picture, suited, booted in NASA, but back in Tumba, this was the situation. This room was a church altar where they are working. You can see the part of altar. This was the Tumba church where the space program started. So they are working on that, and they are putting together a sounding rocket. And imagine, I mean, later Dr. Arvamudan has written in his book, both of them were close friends. He was called Dan Arvamudan. So he has written in his book that there was no fan in that room. Forget about ACs. Today we are sitting in this fantastic room even to talk about space technology. But imagine a situation. I mean, when I wrote about computer technology, I came to know that when the first computer in TIFR was installed and the first computer in IIT Kanpur was installed, they didn't have AC for a long time. For 1 month, they had to just wait for AC to come because centralized AC or forget about any kind of air conditioning was not heard of in India and any great institution. So they had to wait for these computers to install, for AC to be, for computers to work, for the AC to be installed. So here they didn't even have a fan. So he said that I removed my shirt and this picture was taken. Anybody can tell me who took this iconic picture? Any idea? Any guesses? No, that's a natural name to come, but Raghurai was still, of course, he was not that big as he became later. Sarabhai was, no, he didn't, of course he loved photography, but this was not taken by him. As I said, India in the 60s was a nation on the move. There's so many things happening. Research was being planned, steel plants were being built. So, as we talked today, there was a talk that, India is a country which is, full of promises. So, one French photographer came to shoot various installations where Bhakranangal was being built and so many dams. So, he also went to Thumba. Henri Cartier-Bresson. So he's a iconic, several of his pictures are iconic. So this was taken by Bresson and it became iconic. So he happened to visit Thumba on that day. This is another iconic picture taken by, where, this was there in the movie which you're talking of. This was there in the movie. Yeah. Yeah, they were carrying. So the idea was that, that of course there were non-motorable roads. Perhaps it was full of slush and
bumpy roads.
Yeah, bumpy roads. So within the complex, people would carry the rocket parts. So this is again a reminder that what kind of problems you can face when you start doing things from ground zero with absolutely no labs, absolutely no facilities, and just handful of people with a lot of dreams. So this was again an iconic picture. And not only this, when as I said, Sarabhai thought that you have to convince policymakers that space has a potential to do. I mean, you can't just tell that today we are launching the sounding rocket and tomorrow we'll be doing satellites and then we'll have rockets. But you demonstrate. I mean, policymakers, when you have to put money, taxpayers' money, they have to be convinced. So one of the applications which Sarabhai thought that India could have was remote sensing. Today, our phones have all the remote sensing images, but imagine when the very first satellite for Earth observation was launched, Landsat, in the late 60s and early 70s. He thought, okay, this technology has a potential for mapping our resources, for water, movement, for, kind of prediction of diseases, for crop monitoring. All those applications he had in mind. But how do we demonstrate it to the policymakers without a satellite? So what he did was, of course, before remote sensing satellites came into being, aircrafts were used for aerial surveys, what you used to call. In 50s, we had a lot of aerial surveys for atomic resources and other mining areas. But all those aircrafts came from US equipped with, machines and cameras and all that, and we had to pay millions of dollars for that. So that knowledge was there. So what Sarabhai did, again, out of box thinking, that's why ISRO is known for frugal innovation. So this example I'm giving is of frugal innovation. So there was a helicopter which the Soviets had given for Tumba, for various you have to chase this sounding rockets in helicopters and where they fall and all that. So for that purpose they had given. So he had that helicopter at his disposal, and he somehow got a camera imported from NASA, loaned, not imported. He convinced NASA to loan a camera, so that American camera was fitted on a Russian for a Soviet helicopter, and the first remote sensing survey was done on a helicopter. Because the problem was that, again, Dr. Swaminathan was involved in this experiment. He said that a particular disease is occurring in the coconut plantations in Kerala. And Tumba, of course, was in Kerala. So, is there any way we can predict onset of this disease before it really starts killing the plantations? So, with that kind of a problem, which they needed to solve, they did this experiment of having this helicopter move over certain defined areas. And how do you define the area? They burned some small fires along at several places to kind of navigate the helicopter in a particular area. And the imagery that it yielded showed that certain top leaves of certain plants had a different color. So that data was analyzed, and that became an indicator that this particular disease is going to occur in those particular plants. So it was kind of an early prediction of a disease which was hitting the coconut plantations in Kerala. So with this data, he made a presentation to the Prime Minister Indira Gandhi, saying that here is a new technology which is emerging, remote sensing, which can be used for this particular purpose. So it was an experiment to show that how remote sensing can be used. We didn't have a satellite, we didn't have trained people, just a couple of them were trained in US in remote sensing, because you needed knowledge, you needed how special cameras, it is not just taking the pictures, they are taking some spectral images which needed to be analyzed to tell you that this color means this particular damage, or it corresponds to a particular happening in the plant. So this was done, and the policymakers were convinced that, okay, yes, space technology can be used for a particular purpose. So this is how the demonstration was done. And imagine, all this is happening before ISRO was formally formed. One of the unfortunate things in India is when we talk about our institutions, we go by a date. The date is 15th August 1969 when the ISRO was formed. But all the things which I have talked are pre-formation of ISRO, because they are all being conducted as part of Department of Atomic Energy. So when we are saying India entered the space age in 1969, some people make fun that when man landed on the moon in 1969, we were not doing anything in India. No, there was a lot of work which had gone already, 15 years of work before ISRO was formed. All these people, Kalam and everybody, was recruited much before. So formation of a particular organization took that is associated with that date, and that was within DAE. The budget was of ISRO came from DAE. It didn't have a separate budget. Sisodiaji would know the financial implications of that. So it did not have that autonomy. Of course, it became an independent department in 1971. So all this was happening. So that's what interests me, is that looking at how institutions also form, what goes into that thinking of behind those institutions. So institutions are not formed suddenly on a particular date. There's a lot of prehistory to each of them, and that's what is quite fascinating. And that's where the thinking comes, that's where the people come, and the policies, and Of course, these are all, again, pictures are from Tulse, and here you can see one future president of India and two future chairmen of ISRO in this picture. And that is Madhavan Nair, that is U.R. Rao and Madhavan Nair, and Dr. Kalam sitting there with this foreign scientist. So you can just see how motivated this bunch of people were, all young people in their 30s, and they could have easily gone to any other university and work, and many of them had offers to work, and of course some did join, but they are all motivated to do something, and that's what the job of a leader is. That is what Sarabhai told them, that, okay, he gave them the promise that, okay, space is something which is going to be big in future. So they joined on that promise, and so there's a good bunch of people there. This again is a familiar picture I mentioned at the beginning. Any young people can tell what is this picture about?
Aryabhatta.
Yeah. The question was for the backbenchers. So as I said in the beginning, we are celebrating 50 years of Aryabhatta this month. On 12th or 13th February it went up. So this was the first India-made object to reach outer space. This is the first Indian satellite made in India but launched from Soviet Union, because we didn't have the launching facility by the time this happened in 1975. And there is again a story behind this picture, this particular satellite. And of course, Sarabhai was not there when this happened, but the planning happened when he was pretty much there in 1971. And as I talked about the Cold War geopolitics, so we had this treaty with the USSR, Indo-USSR Friendship Treaty. And one of the subjects in which the USSR wanted to collaborate with India was space. There are several other things, medicine, meteorology, and several other things. So space was also included. So ISRO was sounded that can you do something with the Soviets? So of course, Sarabhai had already planned a small satellite. And one thing which you should remember about space, basic thing, there are three components of any space system when we are talking what is space technology. You need to have a rocket, you need to have a satellite for application, and you need to have a launching capability. So you needed a rocket, you needed a satellite, and you needed applications. It should do something. There's no point in just sending a rocket. So as a rocket, remote sensing is an application. So you needed all the three, and everything needed expertise. So what ISRO, Sarabhai's vision was that we will work on all the three components in parallel. We could not have waited for a rocket to be ready. It came in 1980 and much later. The SLV-3 became success in 1980. So should we develop the rocket technology first, then develop a satellite and then applications? No. He said we'll work on it all together. So applications we worked on together. In the beginning, we started working on rocket technology. We also started working on satellites. So he had planned that a satellite India should make and we should launch it from USA. But when this offer came from Soviet Union, they changed the plan and they said, okay, let's talk to the Soviets and what they have in mind. So this talk happened, it's a political talk with the diplomats and secretaries and cabinet secretaries and DP Dhar and others. So by that time, incidentally, China had already launched one of its very early satellites. So the Soviet ambassador asked in this meeting when U.R. Rao and Satish Dhawan and Sarabhai was there at that time, that what is the weight of the Chinese satellite? So they found out and said it's about 100 kgs. So he said the Soviet Union is going to help you, provided the weight of the Indian satellite is going to be heavier than the Soviet one, as on the Chinese one. But here was Sarabhai and the team planning for a 100 kg satellite, and this was 190 kg. So they went back to the drawing board and then they designed this, and this was 358 kgs. So it took time from 71 to 75. But of course they could do, and this was much heavier than the Chinese satellite. So the idea, why was this satellite a breakthrough? Of course it reached the orbit and it did some data collection, but there was a partial failure, so it remained in the orbit for a long time, but data stopped coming. So but we demonstrated that it could reach an orbit and a desired orbit and remain there. So that was a technological leap for India. But it was such a great engineering marvel at that time, because again to put together something which is going to space and remain there was not easy. Although we didn't launch it from India, but it was all made in India by our scientists, U.R. Rao and others. And incidentally, U.R. Rao was the only scientist who was engineer who was exposed to satellite technology by that time. So he had a team of young people, and they did develop this. But the main problem was that how do you procure all the things which go into the satellite? You need space grade material. The metals, the electronics, the wires, the connectors, and the systems which you use on Earth are not suitable for lasting in space. So what you need is something of space grade components, subsystems, electronics, switches, and everything. And we didn't have an industry doing that because there was practically no aerospace industry other than HAL, and they were not into space grade making stuff which was space grade. So again, bureaucracy comes into play. That we had foreign exchange shortage, we had long procedures to procure. If you wanted something to get from US or Europe or anywhere, you needed permissions. So that would have taken a long time. So again, an example of out-of-box thinking was Satish Dhawan was the chairperson, and that chairman of ISRO at that time, and Sarabhai had passed away. He constituted a 3-member committee. And U.R. Rao was the project manager. Then most unlikely of the person is T.N. Seshan. You always remember him as the man who did wonders at the Election Commission. But before that, he did wonders in the Department of Space. He was there for almost, I think, 15 to 17 years as the additional secretary, because secretary is always a scientist. So he was the next man heading the administration. So he was the second member of this committee. And the third member was Y.S. Rajan, who was the scientific secretary to the chairman. So the idea of this 3-member committee, U.R. Rao knew what the stuff which we need for this satellite. But how do you procure them going through all the procedure?
So you can take 5 to 10 minutes more, otherwise the time is over.
Okay. Thanks for the notice. So this committee visited with a shopping list to US, France, and Britain. And it was formally called a purchase committee or whatever which was acceptable to the rules. And they kind of talked to the people selling this space grade material, selected them, and booked the purchase order immediately. The committee met in these places and they approved, and so that's how the bureaucratic hurdles were overcome, that the purchase committee should sit here and the orders should come to place from here. So that was overcome. So again, it's an example of how do you work with the government rules. At the same time, you try to do things in a different way. That's how this was overcome, and within 4 years, this satellite got ready. Of course, it was big news. I don't know how many of the people would have seen a 2 rupee note, but it was Aryabhatta was put on 2 rupee note, then Soviet Union put on its ticket. So it was a big news at that time. There's a story about how and why Aryabhatta was named so, but I'll skip that now. I can tell you later. This is one of the recent pictures of a Vikas liquid propulsion engine being tested. This is the heart of our rockets today. I'm not taking you through the chronological development of the rockets. I'm going to skip all that story. But this is a very crucial part in that rocket development. As we know, Polar Satellite Launch Vehicle is one of our most successful rockets, which has undertaken several flights, several consecutively successful flights, and it launched Chandrayaan and Mangalyaan also, Mars orbiter mission. But the heart of that rocket is a liquid propulsion system. See, the rocket has different stages. There's a solid propellant, there's a liquid stage, and then there's a cryogenic stage. And each one has its own complexities. So this was in the 80s that how this technology, 70s in fact, as I said, parallelly we were working on Aryabhatta, parallelly we were also working in the technology. So this was the time when French agency CNES was working on its Viking liquid propulsion engine for the Ariane rocket. And they were also a bit like ISRO. So they wanted to collaborate with ISRO, and they made a very interesting proposal. And again, it was negotiated by T.N. Seshan. it was a kind of a barter agreement. There was a technology development through barter is unheard of, but this is what ISRO did. What CNES, the French agency, proposed was that they needed a particular kind of equipment called pressure transducers, which was to go in their several systems, and they needed it in not in hundreds or dozens or hundred, but in thousands. They needed 7,000 of them, and they wanted it to be outsourced. And they said, you make these transducers in India, we'll give you technology for that. In return, you send some 40, 50 of your engineers to work with us while we develop the Viking engine. There was no money involved in this whole technology development deal. We made transducers in India. We supplied to them. They were made in Bangalore. And they included 40 ISRO engineers in the teams which were developing the liquid propulsion engine for Viking. So there was a team put back at ISRO in Bangalore that whatever these 40 people would learn, they'll transfer that technology, not in writing through drawings or anything, but whatever they learn, they'll transfer man to man to scientists in India. And that's how the liquid engine for PSLV was developed, and which is the core of our. So before cryogenic, this was the story. Cryogenic became big for several other reasons, but this was again out-of-box thinking, and Session gave it a name. He said, this is an Indian version of Viking, but we can't call it Viking because our people have worked on it together with the French, and we have developed it here. So it's not as if Viking technology has been transferred, so we have developed. So let's call it Vikas. And Vikas was an acronym for Vikram Sarabhai. Vikram Ambalal Sarabhai. So he said, let us call it Vikas. So that is a name given by Sarabhai. Sorry.
Sharma ji, thoda sa.
Yeah. So in the introduction, we mentioned about this satellite being carried on bullock cart. But it was not for lack of a transport system. Again, it was an example of frugal innovation. A particular test needed to be done on a satellite in an environment which was free of electromagnetic radiation. And to create that environment would have taken millions of dollars of investment, or sending the satellite, this was an Apple satellite, to another country for tests. So they thought of a novel way of doing that. It can be done on a bullock cart which had rubber tires at the. So this was done at, I think the scientists have written that 140 rupees we could do that. And so again, it's a frugal innovation. It's not a shortcut. They produced a paper, it produced the data, and it was accepted in scientific journals that the same kind of the data could be produced in a facility which was worth millions of dollars compared to this. So there are several examples of innovation like that. So this is the story of Rakesh Sharma. It's a long story. If you want, I can go over it, or no, because you will have some time for question answer also. No, it's in short, it's again a geopolitical project. You see, when USSR wanted to, they developed this space station where they had the technology where they could send in the Soyuz spacecraft astronauts who could live on this Salyut station for a few weeks. They had 11 countries which were in the USSR kind of a communist bloc, which incidentally included at that time Cuba, Mongolia, Vietnam. So astronauts from 11 countries were sent by USSR to Salyut. And then as a 12th country, they proposed that India should also join that. The proposal was originally made to Morarji Desai, but he said no. Because he reminded the scientists that this is what Sarabhai had said, that we don't have fantasy to send humans to outer space. That is not the goal of ISRO. And ISRO also agreed with Morarji's decision, because they had too many things on their plate. So it was not being arrogant on part of ISRO to say no, but they had too many things on their plate and their priorities were different, so they said no. But the proposal came back from Soviets again when Mrs. Gandhi came back to power in 1980, and she said yes. But since already ISRO had said no, she put IAF to do this task. Therefore, the selection of astronauts was done by Indian Air Force, not by ISRO. In the official histories of ISRO, this flight is not mentioned. The book which they published, they don't mention Rakesh Sharma's flight because they don't. It was not an ISRO project as such. It was an IAF project, and of course, Mrs. Gandhi asked ISRO to help them out in the selection and all the process. So ISRO said, yeah, this is not what something which we would like to do. So but imagine, again this episode tells us that here was a space agency, a government department saying no to what the Prime Minister has said, and Prime Minister is agreeing, seeing the logic why ISRO is saying so, and then putting, so this kind of shows the relations between the top political leadership and ISRO at that time, I would say. Of course, Rakesh Sharma, we have just celebrated the anniversary. This is the capsule in which he returned. It's physically kept when I took this picture in Nehru Planetarium in Delhi, but now they are revamping the exhibition, so I don't know if it is there. This is the capsule in which he returned to. Then it was donated by USSR to India. This is a picture I took in Rajasthan in Nagaur when I happened to be on the on a Janmashtami day. And this is just to show how people connect with space. And this is the Chandrayaan-3 when it became a success with the rover. This is the Pragyan rover. So it caught the imagination of people that, it is something which people connect with a great deal. And again, Kasturi Rangan, I'll stop here in 2 minutes. Dr. Kasturi Rangan's period is very crucial because this is when ISRO deviated from what Sarabhai had said. If you strictly followed the blueprint of Sarabhai, India should not have gone into outer space with Chandrayaan and Mars orbiter mission, but he justified that. And the political leadership of the day saw merit in what Kasturi Rangan suggested. And Prime Minister at that time was Mr. Vajpayee. He said, I have no objection to what you're saying, but I want you to build a political consensus on this. And he sent the matter to the standing committee, parliamentary standing committee, which had members from all the parties. It was debated there, and the parliamentary standing committee said yes. So ISRO deviated from the path with due consensus, national consensus. ISRO also consulted the larger scientific community, the scientific academies, and so that exercise was gone through. So there was a deviation, and then, it was done. So ISRO, and of course, the discovery of water molecules which happened so Chandrayaan-1, according to me, was a greater scientific achievement than Chandrayaan-3, which had its own technological breakthroughs. And again, this is the 4 astronauts. So the next logical step was to go to send humans from India. Rakesh Sharma went to space from USSR soil. So after that, we have not had an Indian going to space from India. So this is what is going to happen. But notice this, that these 4 gentlemen who were selected by ISRO were trained in Russia. But the only difference between that USSR and this thing is that time it was a friendly gesture on part of the Soviet Union to train. There was no money involved in whatever Rakesh Sharma did. But now the Russian agency trains astronauts on you can pay the money and get that done. So I'm coming to my last slide. Of course, this is the mock-up module in which these 2 or 3 of the gentlemen, the astronauts, would go up. And this is the Gaganyaan module, which is undergoing tests. So what is the big picture that emerges from what I have said? Of course, I have given you some pointers. You need a vision, both political vision as scientific vision, what you want to do, and a blueprint to implement that. And that's what ISRO has done. And continued political support, irrespective, barring for a few months or a couple of years when ISRO faced a resource crunch, when Mr. Charan Singh was the finance minister, and he said, we are not going to give you money, what you're doing is not what India needs. Barring that period, we had no problem in the space, the political support for the space program. Of course, I talked about the high-class technical manpower which is needed. Now you don't have to send people abroad. We have a huge pool of resources. It's the manpower, out-of-box thinking. I've given you several examples of what ISRO does, frugal innovation, out-of-box thinking. Yeah. And long-term planning. Imagine when you're talking of Gaganyaan today, the first DPR for Gaganyaan was put in 2006. The first thought came in 2003. So imagine the kind of planning that goes on. We have been 20 years and it's going to take another, I suppose, 2 years for it to go up, and we are already in 2025. So you need long-term planning for all your space missions. And ISRO has extensive failure analysis. I have described in my book that the 3-4 launches which I covered from ISRO all failed. So I mean, we make fun of that. It's a SLV was given the name that sea-loving vehicle. ASLV was giving the name always sea-loving vehicle, so it went down. But yeah, those jokes apart, ISRO has an extensive failure analysis mechanism, which includes outsiders, peer reviews, team members. In a team member, there's no leader. Everybody has an equal say. So that are all part of ISRO culture. I mean, very few government organizations, I would say, have a mechanism to analyze their own failures and act on that. And of course, there are many challenges which we face now. We want to build our own station, which China has already done. Should we do that? And there are restrictions on the kind of rocket system we have. If you really want to build an Indian space station, we need far more, we need to triple our launch capacity currently. There are several challenges ahead. The whole system has changed, right from the Baba's vision to the last chairman of ISRO saying that we want to be a space power. So from a situation where we are wanting to use it for national development, today we are having a vision of becoming a space power. So that has its own challenges. So I'll stop here, and that's all. Thank you.
Thank you. Thank you very much, Dr. Sharma, for your very informative talk on the subject. Now we can go ahead for the question and answer session. Anyone?
Dr. Sharma, thank you for your talk. It was
पहले आप introduce करिए क्या? What's your name?
Manish Bansal.
Manish.
Yes. So I have a question. There's obviously a lot to be proud of the Indian space program. But as the next stage, do you think that we are kind of like falling behind in terms of the innovation which is going on, reusable rockets? Private sector has taken over like 90% of the launches which is happening. So how do you think that is going to affect our future space program?
Any other question? Then we can take it together. Yeah, that's one aspect which I didn't cover. Yeah, that's when I talked about the challenges. That's one, because globally, if you see the space, the dynamics and the landscape of space industry is changing. Instead of thinking of one big satellite costing $200 million, people are thinking of a cluster of satellites, micro satellites, pico satellites, And so you're de-risking, so one thing fails, your whole system comes to a standstill. But if you launch 1,000 satellites, micro satellites, and 2 or 3 or 5 or 10 of them fail, you can still run the system. So yes, it is happening. And ISRO, of course, is thinking of that. And as you know, that it's been opened up for the space sector. And there is some movement. People are developing the future, like propulsion system, electric propulsion systems are being developed, but on a smaller scale. I think that thrust is still to be there. You can't compare the Indian private sector with Elon Musk saying that, he has already demonstrated the reusable rockets and, things which can be, noodle catch where, it's caught. We have seen all those development, but it needs a lot of investments at that time. But don't forget that the private sector, which is being promoted in US, has a lot of backing from NASA. Billions of dollars of investment from NASA has gone into Blue Origin, Elon Musk and all that. And all the former NASA guys are working there. Elon Musk is not a technologist. He's a good leader, I would say. So that has to happen. So we are still lacking. We have our national restrictions. And even if you think of compared with China, China has already a space station in orbit. We are thinking of 2035. Full-fledged space station. China has already done it. So yes, those challenges are there. But we have always gone in a manner where we can manage things and looking at our national priorities. I think that's where, of course, the private sector has a big role to play. But can you allow them to launch their own satellites, or any of that billion-dollar investment going from private sector? I don't see that. None of our billionaires have put money in the. All the startups are working, but none of the billionaires have put their money in the space sector. Unless that happens, and ISRO can always, I suppose, handhold them. Yeah.
Thank you, Dr. Sharma. I'm
Bye.
Rajendra Banawat. I just wondering, how do you regulate the space in the space when satellites are launched, and is there any regulation for regulating the space in the space? Or can you throw some light on that?
Yeah, there are international regulations. How many satellites can be launched in particular, orbits, and what, configurations, and there are restrictions. There are international bodies, but and you have to book those slots in much in advance. Therefore, the long-term planning, which I mentioned, is required for that. If you are planning to launch a satellite 5 years later in a particular slot, you need to book that slot. So yes, there are regulations, and therefore agencies plan to do that. Yeah. And now there are other issues like space debris. What do you do with the satellites which have gone deused? So now there are technologies where they can recover the debris and bring back to Earth. So all those sustainability issues in the space environment, those are the big challenges. Yes, that's a big challenge.
Normally debris are dumped into the sea.
No, there are some debris moving around in the space also.
Space itself,
Yeah,
yeah.
so you need to bring them down, because even a speck of a debris can damage your satellite. No. And to monitor those debris, all those are challenging aspects. So anti-collision, technologies have to be developed. Even when ISRO launches its satellites, they need to look at the window where it is not going to collide with some debris. So yeah, all that is those are the big challenges.
What is the organization called? Is there a name of the organization which controls and regulates these types of things?
Yeah, there is. I'm not able to recall the name, but there is an international regulation for all the space. Yeah, it's part of ITU, or there is a subcommittee or something like that.
Thanks for insightful this information. I am Devesh Bansal. So just I want to share, I
Where
think
is that?
ISRO is the only first agency under government which is developing now reusable launching vehicles. So to my knowledge, 3 stages has been done because my son is working with a company who is involved in the launch of this developing reusable launching vehicles.
Yeah.
So ISRO is the first agency in world
No.
which is a government agency. Private sector companies are having that reusable vehicles.
No, I'm not sure if European Space Agency or NASA have done it, but yeah, see, reusable technology is one where everybody has to go, but I mean, we are only experimenting, which is a long way to go. But I'm not sure if ISRO is the only government agency to do. I'll have to check. But yeah, that's the way forward. And ISRO has that RLU, reusable launch vehicle. It has a couple of experiments. It has not gone into full flight, but they are trying to do that. Yeah, I mean, those things go on in parallel. Number of futuristic projects are there. Again, Kalam was the first one to imagine a hyperplane at that time in the 80s.
Yeah, can I ask something, sir?
Yeah,
This is
yeah,
Shashwat,
sure,
sir.
sure.
Why Elon Musk is claiming that the US space station has lived its life and it should be dismantled? Some light around it?
Yeah, it will be. I think the design life ends in another 5 years. Like all the earlier space stations have been dismantled. Like Mir was there, the Russians was there in the orbit for 25 years. Before that, Salyut was there for short period. Skylab was there, if you remember, in the 70s. It fell in the debris. There was a big scare in India. So yes, it has a design life. But NASA has not said whether it is going to keep it alive. Sometimes keeping them alive for a longer period itself might cost a lot. So yeah, at some point I think it will. See, the problem with, as scientists say, that they are all in the low Earth orbit, LEO. So every few rotations around the Earth, the LEO keeps changing. So it is bound to get deorbit at some point, which they know. They keep planning for that. So they will have to destroy it after some time. Yes, it is bound to happen.
और कोई? Yes.
Namaste, sir. My name is Kumar. You mentioned several times about China's success. So, what we can learn from China? Because at a similar time, they started their space program, but they are much ahead now.
No, the thing is, of course, I don't know, I have not studied the Chinese program in minutely or how they have done it. But the thing is, every country has its own priorities, you know. They started slightly later than us in terms of, you know, application satellite, but we in terms of several other things, we were the first one to reach, you know, Mars orbit. Of course, they landed on moon, and they also done a sample return also. I mean, not only they have landed, they have collected the samples and they have come back also. So in some areas they are ahead. Some areas, of course, as I said, they have built the space station. One thing, of course, is it's a question of national priorities. Can you, you know, commit nationally that will fund ISRO $5 billion for next 10 years with these goals? If that political commitment is there, we can do. But there might be issues with that. You know, should we do that as a nation? Should we commit that? As I said, human space mission, we have taken 20 years for it to come to this stage where we are talking of a couple of more years for it to go. So I think it's a question of national priorities. But if you think of developing uh, capabilities which we have done, scientific capabilities like our Aditya, the mission to the to study the moon, which is much ahead of several others. So now we are going to, sorry, sun, and we are going to launch this $1 billion satellite, which has been jointly made by India and USA in NASA in a few months from now, which is NISAR. It's the most advanced remote sensing satellite. So in some aspects, scientifically, in reliability, we are much ahead. But yeah, we have not gone in for big missions like sending humans. So that was not our priority at that time, I would say. And of course, it's a question of putting investments in not only the space agency, it's a question of putting investments in R&D in general. We spend less than 1% of GDP on R&D today as a nation. China is, I think, 4 or 5%. So we need to invest not just in ISRO, but in our universities and our national labs. I mean, that's where the science, the technology will come from. No? ISRO is just a technology integrator. It can plan and do things, but it depends on so many others. So we need to develop. I mean, that amount of money that China is putting in R&D is huge. So it is leading in not only in space, but space is what? You need new materials, you need new systems, you need avionics, you need, which is coming from where? Which is coming from industry, which is coming from R&D institutions. So we need to put money in that. Sorry? Yeah, so the quantum of money which goes into R&D is huge that way, no? So not just ISRO or space, you need to put money in R&D as such.
Sir.
What is the extent of private sector participation in India? Do we have a lot of it? Is the promise a great deal, or it's just one doesn't hear much about it? Not is there another Elon Musk emerging in India?
No, there are two aspects to what you asked. Private sector participation in space program has been there for a long time. That ISRO has built capacity in the private sector to supply things which it wants. For example, I said there have been several missions of PSLV. So all the engines are being made in the private sector according to the specifications of ISRO. Like you have Godrej and Boyce, you have L&T, you have several other private sector industries. There are fuel suppliers. Fuel comes from the private sector. So that capability and capacity to develop things for ISRO has been there for a long time. But if you are asking that can private sector do things on its own, that's where we are lacking, because again they need to investment. But there is a core, I would say, number of firms which are able to do things on their own. For example, they did develop some satellites and supply to foreign countries and all that. So that's happening on a small scale. But unless the big corporate houses put money, Airbus and Boeing, Airbus, they are all putting money in aerospace for a long time. No? So we don't have that kind of a industry. Of course, a lot of the the PLI scheme encourages you to put money in the defense sector. So a lot of private sector big guys are going into defense production. But again, that's not a technology development. No, they are always collaborating with foreign companies and doing that. So unless that kind of money goes into aerospace and space industry, we are going to not say a big one like Elon Musk, I would say. Yeah.
So,
Yeah, please.
Good evening, sir. My
Yeah.
name is Ghazal Jain. I want to become a scientist.
oh,
Guide me. How can I prepare myself from today?
पहले तो पढ़ाई करो बेटे अपनी.
You don't have to be under pressure to do things. Whatever you are doing, go on doing your studies, but be always inquisitive. Ask questions to your science teachers, to your maths teachers, to your social studies teacher, because science is all about asking questions, not believing what you are told. So always be curious. That is the key to becoming a scientist. You should have a curious mind. So unless, our teachers, sorry to say that, but we don't have that culture of, encouraging children to ask questions other than what is there in the textbook. So don't believe anything what you're told. Ask questions, how things happen. If it is raining, why it is raining, or how is this bulb working. Ask basic questions to your teacher or try to find out answers for yourself. So always be curious of things around you, things what you see, and do good in maths and science. Just general, that your mother would always tell you maths or science में अच्छे number आने चाहिए. So that's one good thing which Indian parents have done. We have done good in engineering because of our parents' insistence on science and maths. That's what so many scientists tell, that they were encouraged to do well in science. So apart from that, be curious of what you're doing, studying, reading. Yeah.
so thank you very much, Dr. Sharma, for
Thank
your
you.
very informative and interesting talk on the subject India's Ascent, the Untold Space Story, in a very simple and interesting manner. Thank you once again.
Thank you. It was my pleasure. Thank you for inviting.
Thank you so much. Always be curious. The perfect end to Jigyasa Talk series.
Yes.
The addition of Untold to the title, sir, was apt, as we got to know of many unheard stories of India's space journey. For more stories, sir's books are available outside, including signed copies. A huge thanks to our chair, Mr. Sahai, and the speaker, Dr. Dinesh Sharma.
Thank you.
Thanks to Mr. Narendra Sisodia, our director, RIC, Mr. Nihal Chand Goyal, and the entire galaxy of RIC. And most importantly, in space terminology, our stars, the audience. Thank you for coming. Have a lovely evening.
Thank you.